Hello everyone. So today we will have an example problem on consolidation, and the topic is referred from the book by Das and Sivakugan, which is the Fundamentals of Geotechnical Engineering, 5th edition. So this problem relates to the calculation of primary consolidation. The soil profile at the site is shown in the figure below, which has a layer of sand and clay. The moist and saturated unit weight of sand are 17 kilonewton per cubic meter and 20 kilonewton per cubic meter respectively. So let us write here, the moist unit weight is equal to 17 kilonewton per cubic meter, while the saturated unit weight here of sand is 20 kilonewton per cubic meter. Then a soil specimen was taken from the middle of the clay layer, and it is subjected to a consolidation test. And the result of the consolidation test shows that the moisture content, or W, is equal to 22.5%. These are some of the given values. The specific gravity, or G sub S, is equal to 2.72. And then the pre-consolidation pressure, or sigma C prime, is equal to 110 or 110 kilonewton per square meter. While compression index, or C sub C, is given to be 0.52, and the swelling index, or C sub S, of 0.06. So the question here is, letter A, is the clay normally consolidated or over-consolidated? So that's the question. If it's over-consolidated, what is the over-consolidation ratio? Okay. And the second question is, if a 2-meter high compacted fill having a unit weight of 20 kilonewton per cubic meter is being placed on top of the ground, what would be the final consolidation settlement? Okay. So the first question is, we have to identify if the soil is normally consolidated or over-consolidated, and if it's over-consolidated, what is the over-consolidation ratio? Now, the second question is, if we put a surcharge of compacted fill, which is 2-meter high, with having a unit weight of 20 kilonewton per cubic meter, what is the final consolidation settlement? Okay, to check for the consolidation condition, we have to compare the pre-consolidation pressure with the overburden or the effective stress. We have to compare these two. Pre-consolidation pressure is given to be 110, so this is okay. So we just need to compute for the overburden pressure or the effective stress. Now notice that from this graph, we do not have the value of the saturated unit weight of clay. It is assumed that, or since it is below the ground water table, the clay is considered saturated. And if we will go back to the formula from our soil properties, we can calculate the saturated unit weight using the formula GS plus E, gamma sub W divided by 1 plus E. So let us check if these parameters are available. The specific gravity is given, and this is this one, 2.72. And then the unit weight of water is known, but we do not have the void ratio E. But since this is considered saturated, we have a relationship before, or in our geotechnical engineering one, which is this one, S multiplied by E, which is equal to WGS. This is for saturated clay and S is equal to 100%. So this relation becomes E equals water content multiplied by specific gravity. And our water content is given to be 22.5%. And so we can just substitute the value. We have 0.225 or 22.5% multiplied by the specific gravity of 2.72. So from here, our void ratio can be calculated as 0.612. So we just plug in the value here to solve for the saturated unit weight of clay. And that is equal to our G sub S, or specific gravity, of 2.72 plus the void ratio of 0.612 times the unit weight of water, 9.81. This is in kilonewton per cubic meter, and divided by 1 plus E, which is 0.612. And there we have a saturated unit weight of clay of 20.3 kilonewton per cubic meter. So since we already have the saturated unit weight, we can now solve for the effective stress. Okay, so solving for the effective stress, we have to go back to this figure. So we start from the 2-meter thick sand, and we have the formula. Effective stress is equal to the unit weight of sand multiplied by the thickness of 2 meters plus the second layer of sand is 3 meters, having a saturated unit weight of 20. So this becomes gamma saturated of sand minus gamma water multiplied by 3 meters plus at the center of the clay layer, the thickness of the clay layer is 3 meters, having a saturated unit weight of 20.3. So we have here gamma sat of clay minus unit weight of water multiplied by half of 3 meters, that is 1.5 meters. So let's try to plug in the values. We have 17 kilonewton per cubic meter multiplied by 2 meters plus the saturated unit weight of sand, which is 20, minus 9.81 for the water. This is in kilonewton per cubic meter multiplied by 3 meters. And then plus the saturated unit weight of clay, which is 20.3 meters, minus the unit weight of water, 9.81, in kilonewton per cubic meter multiplied by 1.5 meters. So the effective stress at the middle of the clay layer is equivalent to 80.3 kilonewton per meter. So when we compare this to the pre-consolidation pressure, which is equal to, that is given to be 110, this is less than, the effective stress is less than the pre-consolidation pressure, which means that the soil is, or that the clay is over consolidated. So since the clay is over consolidated, we can solve for the OCR, and the formula is the sigma sub C prime over the effective stress, and that would be 110 divided by 80.3, which is 1.37. So this is the final answer. The soil is over-consolidated, and the over-consolidation is 1.3 or 1.37. Okay. So for our second question, there is a surcharge of, so let's go back to the figure. If an applied pressure delta sigma is given. It should be calculated based on the height of the fill and the unit weight of the fill. So here, for 2-meter high compacted fill, we have a surcharge of 2 meters multiplied by the unit weight given to be 20 kilonewton per cubic meter. So this becomes a pressure of 40 kilonewton per square meter. So therefore, our delta sigma prime is 40 kilonewton per square meter. So since this is over consolidated, we have to use either formulas of OC clays. But before we can identify which formula to use, we have to check again the condition among the surcharge, the effective stress, and the pre-consolidation pressure. So the values are, let's say we have again here the overburden or the effective stress, which is equivalent to 80.3 kilonewton per cubic meter, and then our pre-consolidation pressure of 110 kilonewton per cubic meter. So let us check the condition whether the effective stress plus the surcharge is greater than or less than the pre-consolidation pressure. We have sigma O 80.3 plus delta sigma of 40, and this is 110. And so obviously, sigma sub O prime plus delta sigma prime is greater than our pre-consolidation pressure. Therefore, with this condition, the equation to use would be primary settlement is equivalent to C sub S H over 1 plus E sub O log of pre-consolidation pressure all over the effective stress plus C sub C, that's H, over 1 plus E sub O log of effective stress plus a surcharge over the pre-consolidation pressure. So let's see if all the parameters in the equations are given. We have the swell index and the compression index. Let's see. Let's go back to the given values. Yes. C sub C and C sub S are given. H is given. E sub O has been computed. And the other parameters are also given. The sigma sub naught prime and the pre-consolidation stress. So we just simply plug in these values to our formula. Our C sub S is given to be 0.06, and then our H is 3 meters, or let us say 3000 mm, divided by 1 plus E sub O, or where is our E sub O? That is 0.612 here. 0.612 log of the pre-consolidation, which is 110 divided by 80.3, plus our C sub C is given to be 0.52 multiplied by, again, 3000 divided by 1 plus 0.612 log of effective stress of 80.3 plus the surcharge of 40 divided by 110. Okay, so simplifying and doing some calculations, we'll arrive at an answer of 52.9 millimeters. So that is the primary consolidation settlement for the given clay values. Thank you.